Part 3, elimination. There are 3 steps. So we've done graphing, we've done substitution, last one, elimination, also called the addition-subtraction method or linear combination. You're going to multiply one or both equations by a constant. You're going to add vertically to find a variable, and you might get a fraction, and substitute that variable back into one of the originals to find the missing. Let's see it played out. Now, I hesitate here because there's so many ways to do this. A lot of students might see, boom, right away, I can just multiply the bottom one by a -2 and cancel out my y's. Some students don't see that at all. Okay, so what I'm going to do is I'm going to do a method that works for every single student, every single problem, every single time. So if you don't like my method and you see a shorter way, use it. That's perfectly fine, okay? So the shorter way on this one is to multiply the bottom equation by -2 to cancel the y's. If you don't see that, here's what you do. Put parentheses around both equations. P.S. These have to be lined up. I should have put a problem in here where they weren't lined up. But you have to have x's over x's. You have to have y's over y's. You have to have constants over constants. All right. See this number on the bottom by x? Put him up top by the first parenthesis. See the number here in front of x? Don't worry about the negative. But does everybody see that too? Put him down here. So you're literally just doing this. Now check. Do you see these 4 numbers? 3 of them need to be one sign. See how 3 of them are positive? 1 of them needs to be an opposite sign. See how that one's negative? That's what you need to check. So right here, you need to make sure 3 out of 4 numbers are the same sign. If you're going to take my method, these 3 out of 4 numbers, those ones right there I'm staring at, 3 have to be positive, 1 has to be negative, or 3 have to be negative and 1 has to be positive. Okay, distribute that in. Boom, 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 boom. 1, 2, 3, 1, 2, 3 on the top and bottom. 3 times -2 is -6x. 3 times +4 is +12y equals 3 times +10 is 30. A lot of students like this method over substitution. 2 times 3 is 6x. 2 times 2 is 4y. 2 times -10 is -20. Do you see what happens here? This will always cancel that. Like a -6 and a +6 will cancel. And now we just mush the other two, equate the stuff together. 12y and 4y is 16y. 30 minus 20 is 10. Divide each side by 16. Y equals, when you reduce, 5/8. People really like this method because once you multiply, it becomes a pretty easy type of problem. I have most students, if they get to pick, they would pick elimination. All right, now we only got this one so far, so we have to take this. So let's see, we have done, this was step number 1 up here where we multiplied. This was step number 2 over here where we solved. Step number 3 is taking your answer and putting it in one of the equations to solve. I'm just going to pick the top one because it's there. So I'll do -2x plus 4, but not 4y, 4 times 5/8, because that's what we got for y, equals 10. That's -2x plus, when you multiply here, you get 5/4 when you reduce. Or, I mean, if you want a decimal, it's going to be a clean-cut decimal, so I'll allow it. It'll be 2.5. So, I mean, like, that's okay. If you want to use a decimal, it's a clean-cut decimal. You may use it. Subtract 2.5. -2x equals, let's go to 7.5. Divide by -2. You know me by now. I like final answers in fractions instead of decimals. So we're going to do 7.5 divided by -2. And we get -15/4 for x. If you have to use a decimal, I guess you could, because this would be a clean-cut decimal. So the solution is x is negative 15 over 4, comma, y is 5 over 8. We're going to practice that one more time. Problem 4. What is the solution of this problem? We're going to try my method of taking this bottom number and putting it on the top, and taking the top number and putting it on the bottom. Focusing on these 4 numbers that you see to the left of my hand. 3 of them have to be positive, 1 of them has to be negative. Well, right now all 4 of them are positive, so I'm going to make my 3 negative. So now it fits the bill. You can only add a negative to the outside numbers. You cannot add a negative to the inside numbers. The one up top already had a negative inside, which is why that was okay. So now I have 1, 2, 3 positives, 1 negative. I can move on. Okay. Distribute on the top. 1, 2, 3 arcs distributing. That's going to be negative 3 times 2 is negative 6x. Negative 3 times positive 7 is negative 21y. Negative 3 times positive 4 is negative 12. Distribute on the bottom. 1, 2, 3. 2 times 3 is 6x. Plus 2 times 5 is 10y. Equals 2 times negative 5 is negative 10. Again, the x's should cancel. The first term should always cancel, because a negative 6 and a positive 6 makes 0, so we don't write it. Negative 21 and positive 10 makes negative 11y. Equals negative 12 and negative 10 makes negative 22 when you combine your like terms. You're getting closer. Divide each side by negative 11. And you get y equals positive 2. A very nice answer. We like it when the answers look like that. So step 1 was over here. Step 2 is what we just did. Step 3, we're going to take our answer and put it in one of the equations. I like to pick the top one as long as there's no ugly like fractions or anything. So 2x, I'm just picking the original one, plus 7 times 2, which is my y value, equals 4. This is just the first equation from over here. That's 2x plus 14 equals 4, minus 14. 2x equals negative 10. X equals negative 5. The solution is negative 5 for x, 2 for y. That one you probably could have done graphing. It would have been a nice clean answer. That one would have been all right. Okay, so we did 2 graphing, we did 2 substitution, we did 2 eliminations. Now, we're going to do 2 word problems, I know. But let's do these special solutions real fast. So let's say you're solving this and you end up getting, ooh, those cancel, and those cancel. See how that happens? Well, let me ask you, does 0 equal 0? Yeah, it sure does. 0 equals 0. So we would say that that has infinitely many solutions. Okay, you want to have 1 point. Back when we were graphing, if you were to graph them, they would be like that. They would be the exact same line on a graph. All right, but let's say you're solving and you end up getting, oh, these cancel, but these don't. So you get 0 equals, in this case, 0 equals 16. 0 doesn't equal 16. So you would write this one has no solutions. And on a graph, that would be, where's it at? Parallel lines. You would have no solutions. Okay, so if you ever have something cancel all the way out and it looks kind of weird, just check out if it's infinitely many or if it's no solutions. Okay, you can do this. 2 word problems, and I think they'll set themselves up very, very, very nicely for elimination. The school that Stefan goes to is selling tickets for a choral performance. The first day, the ticket sales at the school sold 3 senior citizen tickets and 1 child ticket for $38. The school took in $52 on the second day by selling 3 senior tickets and 2 child. So in my head, what I'm getting at is I see 2 things that are happening. I'm going to call X the senior tickets, I'm going to call Y the child tickets. So you always identify the two things in the problem, okay? So the first day I see we have 3 senior tickets and, let's see, 3 senior tickets, 1 child ticket, and I made $38 total. The second day, well, let's see, they were mean. They were the $52 total, 3 senior tickets, but 2 child tickets. So I have 2 equations. It's not a word problem anymore. You just solve it. All right. If you choose to use elimination on this one, you put the 3 up here, you put the 3 down here. You have to make one of them negative, so you have 3 positives and a negative, and then you solve. By the way, some of you might be thinking to yourselves, can't I just multiply the top one by -1 and solve? Absolutely. But we're going to do it this way. So you get -9x, do it however you want as long as you get the right answer, by the way, minus 3y equals 38 times -3 is -114. Oh, sorry, my left hand was in the way. On the bottom, you get 9x plus 6y equals 52 times 3, which is 156. Boop. The x's are going to cancel. -3y and 6y makes 3y. -114 and 156 makes 42. Divide by 3, you get 14 when you divide by 3. Therefore, the child tickets, oops, they sold 14. Oh, that's not how many they sold. Silly me. That's not how many they sold. That was the price that they sold them because they sold 3 of them, it said. There we go. A child ticket sold for $14. Boy, that word child looks really messy. Plug that in to find x. So I will do 3x plus 1 times 14 equals 38. 3x plus 14 equals 38. Take away 14, 3x equals 24. Divide by 3, x is 8. So in this problem, x was the price of a senior ticket. So senior tickets sold for $8 each. Last one, same type of problem. The state fair is a popular field trip destination. This year, the senior class at high school A and the senior class at high school B both went there. The senior class at A rented and filled 8 vans, 8 buses with 240 students. High school B rented 4 vans, 1 bus with 54 students. Every van had the same number as did the buses. Find the number of students in each van and each bus. So I'll make X a van. I'll make Y a bus. All right, let's look at the high school A. So in A, we have 8 vans, so that is 8X, and 8 buses, so that's 8Y, for a total of 240 students. Let's take a look at high school B. 4 vans, so 4X, 1 bus, and that was only 54 students. How about I do substitution on this one, since I did elimination in the last one? I'm going to take my second equation, and I'm going to solve it for y, because that seemed to be the easiest thing to do. So I'm going to save this equation for a later time, okay? So I get 1y equals -4x plus 54. If I divide by 1, I get y equals -4x plus 54. If I put a box around that, I can plug it into my other equation for y. Now, if you wanted to do elimination, I mean, go for it. It really doesn't matter to me as long as you get the right answer. So I'm going to do 8x plus 8 times -4x plus 54 equals 240. Distribute in, so you get 8x minus 32x let's see, 8 times 54 is, that's going to be 432 equals 240. And let's just solve this. 8 minus 32 is negative 24x plus 432 equals 240. Negative 24x, take away 432. I know you're probably done by now, aren't you? So 240, take away 432 is negative 192. Divide each side, and you get 8. Divide by negative 24. You get x equals 8. Okay, so we have how many kids fit in a van. X was how many fit in a van. So we can say x kids in a van. Oh, I said x kids. I meant 8 kids in a van. Now take that and put it in your box. Y equals negative 4 times 8 plus 54. That's negative 32. Let's see. Plus 54 makes 22. So we can fit 22 kids or students in a bus. All right. I know by now you're done because I'm done. But I hope you were able to see the 3 different methods. I hope you were able to see that graphing is not the best way, especially for problems that would be fractions as answers. But I hope that you kind of find the way that you like the best, whether that's substitution or elimination. And tomorrow we'll have lots of fun practicing together.